Assalamualaikum and good afternoon everyone. So in this video we will discuss or we will do the revision for the UPS 2, which is about the objective question. The topic that involved is the magnetic field, electromagnetic induction and also the alternating current. As usual, get ready with a piece of paper and please write down on the paper question number 1 to question number 25. In this discussion, I will discuss 25 objective questions from this 3 chapter. Take a look at question number 1. Figure 1 shows point P near to the north and south pole of a bar magnet. The magnetic field at point P is? For question number 2, a bar magnet is divided into two pieces. Which of the following statement is true? Question number 3. The field line pattern around two bars in the figure shows that? Question number 4. An electric current flows into the page. What is the direction of the magnetic field? For question number 5, Figure 2 shows the direction of resultant magnetic field produced by two current carrying straight wire at a point P is into the page. In what direction of the current I1 and I2 to produce it? For question number 6, the magnitude of the magnetic force exerted on the current carrying conductor in a uniform magnetic field is depends on all physical quantities below except? For question number 7, increasing the current flow through the conductor dash the force on the conductor. Question number 8, Figure shows two parallel wires of length L respectively are separated by a distance D. Each wire carries a current I at same direction. The types of force exerted on both wires is? For question number 9, in the mass spectrometer, a charged particle will passing through the velocity selector and then will enter the region consists of a uniform magnetic field only. The motion of the particle in the velocity selector and in the magnetic field region are? Question number 10. Total number of magnetic field line passing through an area is called? Question number 11. Which of the following statement is not true about the magnetic flux? Magnetic flux is? Question number 12. As per Faraday's law of electromagnetic induction, an EMF is induced in a conductor whenever? For question number 13, a magnet bar moves into a solenoid as shown in the figure below. State the direction of the deflection of the galvanometer. For question number 14, the inductance of a solenoid can be increased by inserting a soft iron core into it. The function of the soft iron core is to? Question number 15. The property of coil by which an EMF is induced in it when the current through the coil is changed is known as? For question number 16. Which of the following is not a unit of inductance? Question number 17. Mutually inductance between two magnetically coupled coils depends on. Question number 18. A circuit consists of a capacitor which is connected in series to a lamp of 2.5 volt, 0.3 ampere and a 50 Hz source. The value of 2.5 volt is refers to. Question number 19. Which of the following statement about a pure resistor carrying an AC is true? For question number 20, the graph shows the variation of impedance Z for an AC circuit with frequency. The circuit contains a. For question number 21, the graph shows the variation of impedance Z for an AC circuit with frequency. The circuit contains a. Question number 22. The average power input to a series alternating current circuit is minimum when. Question number 23. What happens when a series RLC circuit is in resonance? Question number 24. Figure shows the graph of XC, XL, R and Z varies with frequency F. At resonant frequency. And last question number 25. The power factor, which is cos phi, is equal to the ratio of the dash to the dash. Now we will discuss the solution for the best answer for this objective question. Okay, for question number 1. Figure shows point P near to the north and south pole of a bar magnet. The magnetic field at point P is, so the answer is, because of the direction of magnetic field line, leave the north pole and enter the south pole. Because of that, the answer is C, to the left at point P. For question number 2, a bar magnet is divided into two pieces. Which of the following statement is true? So, if you look at the diagram, when the bar is divided into two pieces, when the bar magnet divided into two pieces, so the two new bar magnet are created. So the answer is C. For question number 3, the field line pattern around two bars in the figure shows that if you refer to the diagram, the direction of magnetic field leave the north pole and enter the south pole, right? So the pole of both magnet bar is as shown. Because of that, the best answer is D. Both bars are identical permanent magnet with opposite pole adjacent to each other. For question number 4, an electric current flows into the page. What is the direction of the magnetic field? So in this case, if you refer to the diagram, if the electric current enter or flow into the page, so we use the right hand grip rule to identify the direction of the magnetic field. Because of that, the answer for this question is clockwise, the direction of magnetic field. For question number 5, figure 2 shows the direction of the resultant magnetic field produced by the two current carrying straight wire at the point P is into the page. The symbol of cross represent into the page. In what direction of the current I1 and I2 to produce it? So we need to identify the direction of current inside I1 and I2. How we do it? So first we use the right hand grip rule. So when we use the right hand grip rule, the current inside the I1 is supposed to be to the right, so that at point P, the magnetic field is into the page. And for the I2, the current is supposed to be to the left, because of if we use the right hand grip rule, you will get that the direction of magnetic field is into the page at point P. So the best answer is C. I1 is to the right and I2 is to the left. For question number 6, the magnitude of the magnetic force exerted on the current carrying conductor in the uniform magnetic field is depends on all physical quantities below except. So this one we need to refer to the F equation for the magnetic field. FB is equal to IL cross B. Because of that, if you look at the choice given to you, the answer is supposed to be distance. And then for question number 7, increasing the current flow through the conductor dash the force on the conductor. So referring to the equation, which is FB is equal to IL cross B, F is directly proportional to the I, so it will increase the force on the conductor when the current increase. Okay. And then for question number 8, figure shows the two parallel wire of length L respectively are separated by a distance T. Each wire carries a current I at the same direction. The types of force exerted on both wire is, okay, referring to the diagram, first we need to identify magnetic field for I1 using the right hand grip rule. So you will get B1 is upward, and then we use the Fleming left hand rule to identify the force exerted FBI. So you need to identify the force exerted on the I2. And we do the same thing for the I1, which is from the I2, you can identify the B2, okay, using the right hand grip rule. And then from the B2, we use the Fleming left hand rule to identify the force exerted on the first conductor. If you look at the green arrow, shows that the force is attractive force. For question number 9, in the mass spectrometer, a charged particle will pass in through the velocity selector and then will enter the region consists of the uniform magnetic field only. The motion of the particle in the velocity selector and in the magnetic field region are. So in this case, if you remember about the mass spectrometer, when the particle, either electron or proton moving in the velocity selector, the concept is FB is equal to FE. So if FB is equal to FE, magnetic force equal to magnetic field, the particle will move in the straight line path, and when the particle enter the region with the magnetic field only, so magnetic force is equal to the centripetal force. So because of that, the particle will move in the semicircular path. Okay, because of that, the answer is straight path and the semicircular path. For question number 10, the total number of magnetic field line passing through an area is called. So this one we refer to the phi, magnetic flux is equal to BA. B is the magnetic field line. A is the area. Okay? Alright, referring to the equation. And then question number 11, which of the following statement is true about the magnetic flux? Not true, sorry. Statement is not true. So please take a look carefully at the choices given. Magnetic flux is a scalar quantity and the unit, because we refer to the equation of phi, which is equal to B dot A. So the unit is B is Tesla, M is meter square. So Tesla meter square. And then inversely proportional to the number of magnetic field line passing through an area. If you look at that, magnetic flux is directly proportional to the B, right? So that's why the answer is B actually. Okay, this figure just to shows the answer for D. Maximum when the uniform magnetic field B passing through the surface area A with the angle of theta, with the angle of 0 degree, meaning that A and B is 0 degree, so cos 0 is equal to 1. That's why the magnetic field is, the magnetic flux is maximum, meaning that the statement D is true. Okay, for question number 12, as per Faraday's law of electromagnetic induction, an EMF is induced in the conductor whenever, so referring to the equation EMF is equal to the rate of change of magnetic flux, so we suppose the EMF will induce if there is a magnetic flux change. For question number 13, a magnet bar move into the solenoid as shown in the figure below. State the direction of the deflection of the galvanometer. So in this case, first we apply the Lenz's law, where Lenz's law said that if the south pole near to the solenoid, the south pole supposed to like north pole, but Lenz's law said it is supposed to be opposite. So because of it is opposite, that side supposed to be south and then north. After we identified the south and north at the end of the solenoid, we use the right hand grip rule to identify the current flow. Because of that, the current will flow from B to A. So the answer is B. For question number 14, the inductance of a solenoid can be increased by inserting a soft iron core into it. The function of the soft iron core is to increase the flux linkage in the solenoid. So the answer is C. For question number 15, the property of coil by which an EMF is induced in it when the current through the coil is changed is known as. So in this question, the key point is the EMF is induced in it. Because of that, the answer is self-inductance. For question number 16, which of the following is not a unit of inductance? So Henry is the unit for inductance, okay? And then referring to the equation of L, which is equal to negative EMF over di per dt. So the unit for L is also can represent E, which is volt, uh, T is second, and per unit ampere. So C is also the unit for inductance. But for the volt ampere is VI. So actually VI is not, volt ampere is not the unit for inductance. That's why the answer is B. Okay. Can we go to the next question? For question number 17. Mutual inductance between two magnetically coupled coil depends on. So to answer this question, you need to refer to the equation given for the mutual inductance. So it is depends on mu naught, which is permeability of the core, the number of turn, which is represent N, and A is cross section area of their common core, meaning that the answer is all of the above. Okay. And for question number 18, a circuit consists of a capacitor which is connected in series to a lamp 2.5 volt, 0.3 ampere and 50 Hz source. So the value of 2.5 volt is refers to, the answer is all the given values for the resistor such as lamp or heater, it is represent the RMS voltage. So the answer is A. For question number 19, which of the following statement about the pure resistor carrying a current and alternating current is true? So referring to the circuit for the pure resistor, we know that the current and the voltage is in phase. So the best answer is C. And for question number 20, the graph shows the variation of impedance Z for an AC circuit with frequency. So the circuit contains a, so if you refer to this graph and relationship where this is the graph, straight line graph, and impedance is directly proportional to the 1 over F. So impedance directly proportional to the 1 over F is for the pure capacitor circuit. Because of that, the answer is B. For question number 21, the graph shows the variation of impedance Z for an AC circuit with frequency. The circuit contains a, okay, the second in this figure, this is impedance, which is show the graph of impedance directly proportional to the frequency. And for the impedance which is directly proportional to the frequency, it is in a pure inductor. So the answer for question number 21 is A. Okay, for question number 22, the average power input to a series alternating current circuit is minimum when? So, power input minimum meaning maybe it is equal to 0. So, power is equal to 0 only in the power, there is a power input in the circuit if there is a resistor. So, if you look at the choices given, B ada resistor, C also, and D there is a resistor. So the best answer is A. No resistor, only pure capacitor. And question number 23. What happens when the series RLC circuit is in resonance? So in this case, you need to refer to the notes that we have discussed before. What happened at the resonant frequency? And if you look at the choices given to you, one of the point is the voltage across the inductor supposed to equal to the voltage across the capacitor. Because of that, the answer is C. Figure shows the graph of XC, XL, R and Z varies with the frequency F. At resonant frequency, so the resonant frequency is at this point. So what happened at this point? Okay, if you look at the notes at resonant frequency, impedance is minimum. So when impedance is minimum, the current is maximum and XL is equal to XC. So because of that, the best answer is D, which is all above are correct. And the last question is question 25. The power factor, which is cos phi, is equal to the ratio of the, so referring to the equation, we know that the cos phi, instead of real power divided by average power, the cos phi or power factor is also equal to R over Z. So the ratio of the resistance to the impedance, the answer is B. So that's it for the discussion of the UPS2, the revision for the UPS2. I hope that you get the idea and you can answer the question correctly. If I'm not mistaken, there are 20 objective questions that you're supposed to answer. So I wish you all the best. Good luck.